The Cloud Native Toolkit is an asset created by the IBM Garage. It helps unify the developer experience between the IBM Cloud itself and its core platform services and the Red Hat Openshift managed environment. It enables developers to get up and to running quickly and offers production-ready code patterns to enable the delivery of production-ready solutions using a software development lifecycle. When you're building cloud-native microservices, it's really important that the engineering team gets up to speed as quickly as possible with a robust, proven software development lifecycle. And in the industry, there are a number of key technologies and tools that help you achieve that. The Cloud Native Toolkit enables the unification of these tools into a flow that enables code change, continuous integration, testing, continuous delivery, and monitoring, all to work in a unified experience. This approach of bringing development tools on the inside of a development cluster, and they focus on the needs of the development team, continuous integration, code testing, contract testing, API testing, tracing, and then a set of tools that are bound to the development cluster from the outside, operational tools like source code management, artifact management, image registry, logging and monitoring, enable the best of both worlds to come together in a unified development approach. The Cloud Native Toolkit can be easily installed on top of an existing cluster on the IBM Cloud, and it can offer you a choice of tools for many of the key components you need to build out a software development lifecycle. You can choose Jenkins or Tekton as your continuous integration technology. You can use Argo, CD or RASI, or even use IBM Multi-Cloud Manager to offer continuous delivery. Again, these tools are open source and they predominantly help you get started quickly, and then you can choose how to replace them either with enterprise grade services that you provide or operators that you may want to install into your Openshift clusters. The Cloud Native Toolkit is delivered as a Terraform infrastructure as code, and it will provision a resource group and provision access group with the necessary IAM policies to enable developers to be easily added to a development environment and for them to continue to focus on building cloud native microservices. Let's start by giving a demonstration of how easy it is to add a developer to a resource group and give them the access control they need to start to get access to their development environment. I can log into my IBM Cloud account, and from here I can navigate to my resource view, and from there I can look at my resource group, which contains my development cluster and the cloud services that have been bound to that development cluster. From here, it's very easy to add a developer into this resource group, and we can show you how to do that. We'll navigate to the IAM, Identity and Access Management area of the console. We'll navigate to the user list, and we will invite a user to a particular resource group. So I'll invite myself. I can pick the team or the resource group we want to invite them to, and that's how easy it is to add a developer to a resource group and an access group. What we can do then is look at the access group for that resource group, and from here we can see the policies that have been defined that only allow the creation of application content. They do not allow for things to be deleted or services to be created. So this is a locked down development environment ready for developers. The IBM Cloud Console is optimized for cloud services and infrastructure. One of the things we've done with the Cloud Native Toolkit is offer up a developer dashboard that can be used to easily navigate the common tools that you've provisioned inside your cluster or services that you need around that. So we can move to the command line and run a very simple CLI tool. This will surface up the dashboard that's installed within the cluster. And from this dashboard, we can easily navigate to common tools that we need for development. We can also navigate to common catacoders or education material that might be useful for us as a developer. And we can access code patterns that can give us robust microservices that work within this software delivery lifecycle that's been delivered. This development team has been working on a number of microservices that are involved around an inventory and stock management. They are using the developer dashboard to easily navigate out to their source code management, where we can see their web, backend for front-end project, their microservice written in Java Spring, and their UI built with React and Node. From here, we can navigate out to the Openshift console, and we can zoom in on the project where this team has been doing its work. And we can now navigate to the pipelines, and from here we can see that each one of these microservices has a completely green pipeline that is run and deployed. You can see where it builds, tests, has done code analysis, release and tagged. They've built the image to the image registry. They've deployed that image out to a Red Hat OpenShift environment. They've performed a health check, and they've now released the Helm chart out to Artifactory, where we can then deploy that into another environment using continuous delivery. So the team now needs to create a new microservice to complement the product's microservice that's already integrated. So to do that, it's easy to follow through the dashboard and use a code pattern as a starting point. We'll use the TypeScript microservice, and from here, we'll create an instance of that source code in our own Git organization. This is out in the open source IBM GitHub, so we can use a template. We'll change our Git organization. We'll give it a name, which is inventory service stock. We'll give it a description, manage the stock levels, and we'll now create that repository into our Git organization. So this has used the IBM code as a template, and we're now able to then take that and work with it. We're now going to clone that to our local machine. We'll go into that source code and we'll make a minor edit to change its name, as this is a static template. In here we have a Docker file, we have a Helm chart, and we have a Jenkins file which contains a pipeline already pre-configured to enable us to work with it. Let's change the name to match the name of our source code repository, inventory source stock. Let's save that name. Let's now commit this change back to our source repository. At this point, we're now ready to register the pipeline with Openshift. And to do that, we can use another helper function called IGC pipeline, and we'll be creating the pipeline within our inventory project or namespace. We'll provide our user ID, our Git personal access token, we'll say the master branch, and this will go off and register the pipeline. It will copy over the latest values of the pool secrets and the TLS secrets which we need for the build. It will set up the config maps. It will pull in any Tecton components if we're choosing to that, but for Jenkins it will finally register the pipeline with a Jenkins webhook. This will mean any more committed changes will trigger the pipeline automatically. Now that's complete, we can go back to our Openshift and you'll see that that is now registered within our pipeline environment. Now that our pipeline has been configured, we've sped up the view so you can see the pipeline in action, and you can see it's running through all the build stages very quickly, just for demonstration purposes. But ultimately it will complete with an image that's built, and it will be managed and deployed into the image registry, and it would have performed a code analysis, code scan, and it would have verified the APIs, and it will finally release the Helm chart as a version into Artifactory. It will perform a health check, and at that point it will verify that this build was successful. What we can now do is verify that this application is running cleanly in the environment. So you can see the pipeline is completed, and at this point we can move over to our command line, where we will be able to interrogate the endpoints, whether it be an ingress or a root. So we'll interrogate our project inventory. It will pull down the list of routes and ingresses that are available. We can move down to our stock microservice. We can press enter, and that will open up the application and verify that it's now running. And what we can do now is a very simple smoke test, where we can try it out. We'll test that simple API and we'll verify that it's running successfully. We're now in a position to start adding our functionality to this application. As part of the pipeline, we performed a Sonar code analysis. So let's go and have a look at how it performed for our microservice. So we use the dashboard as an easy way to navigate into SonarQube. This will open up the SonarQube admin console, and you can see there's a number of pipelines already publishing their statistics about their application. Let's search for just the inventory project, and let's look at our stock service. We can see that there's 0 bugs in here. We can see that it's got 88% test coverage with 34 unit tests. We can also see that it passed the quality gate. We can also see a microservice that isn't in as good shape. So we can see that we've got limited test coverage. We've got some security hotspots which we can interrogate into. And Sonar gives us a lot more data about how that code is behaving and what we need to do to improve it. So we can look at the other issues that are going on. During the pipeline's using Git tags to tag the release of code. This makes it really easy for the repository to be used in both Tekton and Jenkins, and allows Git to store the baseline of the tagged version. So if we navigate into our stock service, we can see the commits and the source code. We can see all the README. We can go to our commits. We can see each of the developer commits that have been made. But as each pipeline is run, we can see the individual releases that correlate to the build numbers that are stored inside the image registry and Artifactory. As I said, this becomes the source of truth for the versioned release and how that's then used between different pipeline technologies. The next key stage in the pipeline is to build an image, a container image that's stored into the IBM Cloud Image Registry. We return back to the Cloud Console, and from here we can use the hamburger menu to navigate to the Openshift cluster, and from here we can navigate to the registry. We then navigate to our particular geographic region where we're storing it, and this time it's in London. This is where our cluster is deployed. We can go to our namespace for our team. We can have a look at all the various repositories for the different microservices. We can navigate to the individual images. So if we search for our stock image, you'll see this is the microservice that we have. And from here, we can now go in and look at the image and look at the number of versions and the metadata that's contained with it. To complement a container image, we need to package up the Helm chart into a versioned artifact. And we need to store that in an artifact registry so we can combine both the image and the Helm artifact together to be able to release this image into a different test environment using continuous delivery. We can do that by navigating to the artifact management, artifactory console. From in here, we can easily navigate from the dashboard. We can see all the artifacts that are being managed by Artifactory, and we can navigate to our project environment. And within our squad, we can see that we have the various different artifacts all been versioned. So we can move through to the version that was built in our pipeline. And from here, we can expand it and look inside, and we can look at the resources. So we can look at the Helm chart, and then we can look at the values file. Now the team has deployed an application into their development namespace, we need to start focusing on continuous delivery and GitOps. So the way that we can do that is we now need to consume our image from our image registry, and we need to take our Helm repository and our Helm artifact that we versioned. We need to move it into a new namespace. So if we go back to the team, we'll see that they've now created a new inventory test namespace. Within here, we can see that there are no deployments. So they have a running app in their dev, but they don't have anything running in test. So we're going to create, they've already created an inventory GitOps, and we're using branching to represent the different test environments. So the test branch contains our application, and as we go into our GitOps, we can see that we've defined a very minimal Helm configuration that references our app, and we can see that we're referencing the latest version from their dev environment, and it's pointing to the artifact Helm repository. We can also customize the variables so we can tailor the replica count, and we'll do a demonstration of that in a minute. So now we've got the GitOps repo. The next step is we need to use a tool to manage our continuous delivery, and one of the best on the market in open source is Argo. Argo is optimized to act as a tool between your GitOps repo and your deployment. So we can go in and create an application very easily. So we're going to call this inventory service. We're going to add it into our inventory project. We'll make the synchronize automatic. We'll pick our GitOps repo that was and the test branch. And from the test branch, we will select our application definition, stock. We will deploy it into the local cluster, and we'll deploy it into the inventory test namespace, and we'll supply the values file that you saw earlier, which has a replica count of 1. So now that we've created that definition, this will now act and manage the relationship between the GitOps changes, and it will reflect the state of the application in the inventory test namespace. So a few seconds later, it will start synchronizing. So it's now synchronizing between the GitOps configuration and the deployment. And we'll see that it's now managed the deployment and deployed the app, and it's now declaring it's healthy. From here, we can go back to the console and see that we now have our app in that test namespace. We can see that it's deployed, and we can see that one pod is actively running healthily. From here, we can go back to our GitOps and we can make a GitOps change. So all GitOps is allowing us to audit trail and manage changes and roll back any changes. So we're going to increase the scale of our test environment for some extra performance testing. These become part of the common day two activities that a development team need to do, along with logging and monitoring, which you'll see later. Now that we've pushed that change, we can force a sync for demo purposes. This will now synchronize the latest changes from our GitOps, and it will now reflect those changes in our Openshift environment. And if we move back to Openshift, we can see that it is now trying to upscale the application to the replica count that we defined in GitOps. This takes a few seconds as it's trying to deploy multiple copies of the same app, which will be using the service to then route the traffic to. We scroll down, we can now see the four services, sorry, the four pods that have been created, and that now completes a very simple demonstration of why continuous delivery is so powerful with Argo CD. Now that our application is deployed, we now need to consume its API in another microservice. So let's say the backend for front end. The easiest way to do that is to run the microservice, open it up in a test environment. And we can do that by navigating to the command line. And from within the command line, we can open up the application, which we did before for testing. So we'll move down to the stock, open that up in a browser. And if we just add YAML to the end of the URL, this will return the OpenSpec Swagger doc. And from this, we can consume that within Swagger Editor. We can just reference that and import the URL. We can correct the base path that we're planning to release and consume that API. And from here, I can generate either a server or I could generate a consuming client. And our BFF is written in Java. So I'm now going to generate the SDK that I want for Java. And I now have all the source code I need to consume this microservice within a completely different polyglot microservice language. Now that we have our application deployed, it's really important that we can gain access to its internal logging. We can do that easily by navigating out to the IBM Cloud dashboard. From here, we can navigate to our resource list view, which gives us our cloud services. And you can see that we have LogDNA configured and bound to our development cluster. As we go into logging, we can narrow it by our region where our instance is created, and we can open up LogDNA. LogDNA aggregates all the logs from multiple clusters into a single view and will give you a historical view over time. So we can see all the different logs that are coming in from all the different components, and we can look at all the events over time. So 41 million events from this particular cluster. We can narrow down just to the error conditions. So we can filter just the errors and we can zoom in on an incident. Or we can zoom in on a particular application. If you remember, we deployed the inventory stock app. We can now just look at the logs for that individual app. And from here, we can go and problem determinate any of the issues, and we can look at the historical timeline that was running with that. In the same way that we can easily look at logging, it's really easy to go look at the system monitoring that's going on our cluster. To do that, we navigate to the sysdig instance that's configured for our cluster. And from here, we can open that up. And it's the same navigation as for logging. We just narrow it by the region we're deployed the instance in. And we'll go in and view our sysdig dashboard. As that dashboard's displaying, it will allow us to explore from different angles. So at this view, we're looking at the cluster itself, and we're looking at each of the worker nodes, and we're getting a complete cluster view of its CPU utilization, its disk usage, its network traffic, and number of connections. So we can look for incidents at that level. But if we want to look at applications, then we can view it at the containerized application level, and we can look at individual applications. So you can see there's a whole number of different deployed microservices running in that. We can then search for our stock app, and you'll see we have a couple of instances deployed. So we have a development instance, this is the latest release, and then we have an instance that's out in test, which is a release behind. So we can go and look at the individual traffic and individual behavior of that microservice, and then we can run extra tests or validate that this microservice is ready to move up into another level of testing. We can also configure alerts, and we can look at the events and so we can then create some behavioral changes. So we can restrict the number of pods, or we can restrict the number of the amount of disk space and various other things. So we can set alerts. So how can you find out more? Well, the Cloud Native Toolkit comes with some comprehensive documentation. It looks at the horizontal problem, not the vertical, meaning it's looking at how the developer experience end-to-end is used by the development team. It gives you documentation on the tools, optional tools you can install into the cluster. Helps you with getting started with the list of prerequisite. There's tools you need on the command line. Gives a demonstration of the console dashboard. And within the dashboard, you can configure multiple tools to point to the developer tools that are of interest to your environment, including the cloud packs. Includes a command line, which again is a helper tool to assist with some of the automation. Gives you a comprehensive view of each one of the tools and how you can use them, and what service and capability they're offering. Takes you through the administration guide, where you can plan your installation into which environment you want to put it in. Covers multiple environments, IKS, Openshift, and code-ready containers. Shows you how to download the Terraform, put in the API key, and just run the Terraform to deploy it. Final part are the assisting with the code patterns, shows you the simple architecture they support, shows you the benefits that they give to you, gives you links out to the open source repositories. Gives you some practical guides on how you can actually use that in a comprehensive solution. And all that's available out in open source.